So call to transformations review sheet question 5. So this is sketching graphs, sketching our trigonometric graphs, all of which have had a transformation applied. So the first thing to note is we're going from 0 to 360 degrees. So first one, y equals 3 cos x. Now with all of these, it's helpful to first of all do a quick sketch of the basic trig graph. So in this case, what does y equals cos x look like? So y equals cos x, we're going to start at 1 on the y-axis. Lowest point is -1. We cross the x-axis at 90 degrees and 270 degrees. Okay, so then we've got to think about what the transformation is. So in this case, we're doing 3 times cos x, so that means it's a stretch. In this case, the whole right-hand side of the equation has been multiplied by 3. That's the same as writing a third y is cos x. So it's the y direction, and the scale factor is 3. So what this means is, in the y direction, everything's been stretched. Imagine pulling this graph in this direction, parallel to the y-axis. Now an easy way to do these ones for stretches is to look at your axes, and I'm going to multiply all the points I've marked on the y-axis by 3. So now the highest point of the graph would be 3, and the lowest point of the graph would be -3. The crossing points on the x-axis aren't affected because there's no stretch in the x direction. Now this makes it really easy for me to now redraw my graph. So now the maximum is 3, the minimum is -3. Draw my curve in and mark my points where we cross the x-axis. So this graph is ending at 360 degrees. And that gives me the graph of y is 3 cos x. So on to sine x. So y is sine a half x. Again, let's start with a basic sine graph. So sine graph, we start at 0, 0, and goes round in a loop like that. So we have 0, cross the x-axis at 180 degrees, 360 degrees, maximum value on the y is 1, minimum is -1. Let's have a look at this one. What's happened here? X has been replaced by a half x. So that means we're having a stretch in the x direction, so parallel to the x-axis. And the scale factor here is going to be reciprocal of a half, which is 2. So this time, we're taking all our x, all the points on the x-axis, and multiplying by 2, so pulling this graph along. So that means, whereas before it did cross at 0, 0 times 2 is 0, so we still cross at 0. But 180 times 2 is 360, and 360 times 2 is 720. So all I'm going to do now is redraw this so it's in the range we wanted. Now we wanted our graph from 0 to 360 degrees on the x-axis. It's only a stretch in the x, so the y is not affected, so that's 1 and -1. So this time, if we look at our graph, from 0 to 360, it's just going to go up and down. And this maximum point in the middle is now going to be at 180 degrees, because it would have been at 90 degrees here. 90 times 2 is 180. So this is my graph of y is sine a half x. Right, so C, we're starting with our graph of cos x again. So here's my y is cos x graph. And what's happened this time? Well, I've added 2 onto the right hand side of the equation here. So this is a translation, we're adding a number. Okay, and which direction are we going to go? Well, this is as if it's been, the y has been replaced with y minus 2. We're not adding onto the x, we're adding into the y direction, which means it's gone up 2. So the vector was 0, 2. Now this means I've got to take my whole graph and move it plus 2 in the y direction. So what's going to happen here? Well, as before, we know that the maximum and minimum of the graph were at 1 and minus 1, and the sort of middle in the y direction is at 0. So what's going to happen now? Well, this whole graph is going to go up 2. So 1's going to become 3, 0 is going to become 2, and negative 1's going to become 1. So when I redraw my graph now, drawing my axis, x is going to go from 0 to 360 degrees. The y direction now, the graph's going to be entirely above the x-axis. So instead of starting at 1, we're going to start at 3. Our minimum point is going to be at 1, and going back up to 3 at 360 degrees. So we can mark in a few points here on the graph. Before, this was at 180, so it's going to be 180 degrees there. And this is going to be y is cos x plus 2. Now our tan x graph. So let's start by sketching y equals tan x. So y equals tan x is this different shape graph to cos and sine. This is the one with the asymptotes. So these are at 90 and 270. And then we have 0, 180 degrees and 360. Right, so what's happened this time? Well, the transformation this time is we've done, if x has been replaced from y equals tan x with x minus 45 degrees. So we're subtracting a number, which means it's a translation. And we need to change the sign. We're in the x direction. There's no translation in the y direction. Change the sign. It's 45 to the right, this means. So what I've got to do is move all the important points on the graph 45 degrees to the right. So this point that was here is now going to be 45 degrees. The asymptote, which was at 90, is going to be 135. 180 is going to move, so add 45 to 225. 270 degrees was an asymptote, that's going to move along, so it's going to be at 315. And this point here would now be 405. So we're adding 45. So now I can just redraw my graph neatly. It would help here to think about what happens to the graph this side of the y-axis, because as we move this to the right, that's now going to come into focus. So my graph's going to go from here. We're now going to go up here. So first crossing point now is 45 degrees. Then we've got an asymptote, which we say is 135 degrees. And draw in the next line of the graph. And that was at 180, so it's now at 225 degrees. The next asymptote was at 315 degrees. And our graph now goes off, if we stop at 360, it goes off here somewhere. So 360 degrees. So that's our tan x minus 45. Okay, our final graph is y is sine negative x. So let's start again with a quick sketch of a sine x graph. So we know what we're doing. That's y equals sine x. Well, let's see what's happened. What's happened here, the difference between sine x and minus x is x has been replaced by negative x. So this is going to be the reflection in the y-axis. Okay, so there's a reflection in the y-axis. This is our point we're reflecting round. So in this case, it'll probably be handy to sketch the rest of my graph is what's going on backwards here. So what goes on backwards here? Well, the sine wave continues in the same manner. Right, so we're going to do this as a reflection in the y-axis. So, for example, if I took this curve here, that's going to reflect in the y-axis, so it's going to end up there. Now the curve here would be going up there, so when we've reflected it, it's going to go like that. So our reflection in the y-axis is going to go from 0 to 360 degrees. We've taken this part of the curve here, reflected in the y-axis. So our sine curve, in this case, goes like that. So that's why it's sine negative x. This point would still be 180 degrees. And this bit of the graph I haven't drawn in because we don't need it.